Welcome to this Grasshopper tutorial about basic vectors, where we'll be setting up a dynamic field of interacting vectors using vector addition. In this video, we will be using Rhino and Grasshopper to create a field with an overall vector strength and orientation within a defined area, which is then affected by vectors controlled by customizable emitter points, which either attract or repel within an adjustable area. All of the vector fields we create are then summed together and used to orient pieces of geometry of our choosing, from triangles to birds and beyond. In this tutorial, you will learn how to set up vectors, how to rotate them with the vector rotate component, how to sum yet vectors using the addition and mass addition components, more on data structures, including the use of the flip matrix component, and finally, how to orient objects with vectors using orient and construct plane components. Let's get started. We're going to start this example by defining an area in Rhino with a simple rectangular curve. So I'm going to draw a polyline here to do this because I want to be somewhat precise with my dimensions. So I'm just going to start it here, and to do 50 units in the vertical direction, 50 enter, and then click, and 50 units in the horizontal direction, 50 enter, click, and then 50 units back down, click, and then I'm just going to push C to close the polyline. So if you want precise dimensions, that's kind of how you would do it in Rhino. Now we want to import this curve that we've drawn, this rectangle we've drawn, into Grasshopper. So we're going to come here under the first tab, Parameters, Geometry, Curve. Drop that on the canvas, right-click that, and set one curve from Rhino, and that is now being imported into Grasshopper. I'm just going to hide the curve in Rhino, just so we can see that it is in Grasshopper. It has this red color, and so we're good to go forward. Now what we're going to do is we're just going to add a set of random points into this area. So I'm going to come here under the fourth tab, Vector, Grid, and we're going to use this Pop 2D component to do this. And what this does is it takes a two-dimensional area and it adds a random population of points. So I'm just going to drop that curve into the first component, the first input, the region. For the number of points, to start we're going to have around 100 points, but we want to be able to increase that later. So I'm just going to drop a slider, double click the canvas, and I'm just going to type 125. And I'm going to put that in for n, and so now I can increase or decrease the population. Typically when you're setting something up, you want to have fewer items just to make it easier to see what we're doing. So somewhere around 100 points will be fine. And once everything is up and working, we'll try increasing that. We also want a number for the random seed that we can change. So I'm just going to, could just be any number, just so that we can change that later, and this will change the random population. And the P input we're going to leave blank for now. That is if you want to have certain definitely defined points that you want to manually input into the region, you can do that. But for this particular example, we don't need that. So I'm just going to take the outputs of this, and I'm just going to keep it clean, put them into a point parameter, and I'm going to flatten that list. Not absolutely necessary yet, but just so we know that this is a flattened data structure. And I'm going to turn the preview for that off. So now we're going to continue by setting up our initial vectors. And to do that, we're going to simply move the points, a defined number of units in the x direction. And we'll do the vectors between that point and the points that we've moved. So I'm just going to come up here under Transforms, Move, Euclidean Move, and we will move the points in the X direction. So the unit X is here under the fourth tab, vector, vector, unit X, and now we've moved the points 1 unit. I do want to add a slider into the X just so we can define the strength of our initial vectors. And to do that, I'm going to just drop a slider onto the canvas, and let's just say 2.5. And now I can change the amount of that movement. We'll see in just a minute the effect of that on our vectors. So now it's time to start to set up the vectors themselves, and we're going to use this vector 2-point create a vector between 2 points component, and point A will be our base points from our random population, and point B will be the points that we've moved. So we don't see anything happening because the vectors are an abstract concept, but we do want to preview them. This is optional, but I recommend it. So we're just going to come here under the Display tab, Display, Vector, Vector Display, drop that on the canvas, and our anchor point, the input A, will be the first set of points that we've drawn, and then the vectors themselves will be this second set of points. I'm going to turn the preview for this off. I'll keep the preview for the base on for now. And you can kind of see as we change this strength, it will change the kind of amplitude or the strength of our vectors. Finally, to conclude the first part where we're setting up our overall field, I'm going to set up a rotate for these vectors so we can change the overall direction of our vector field. What we don't want to do is, here under Transforms, Euclidean, there's a rotate command. This is not the one we want. This is to rotate geometry. To rotate the vectors themselves, we need a special vector rotate component, and that is here under the fourth tab, the Vectors tab, Vector, Vector, and this last one here, it just says rotate, but it's actually rotate the vector. And the hint that you've got the correct one is if it has a V rotate, vector rotate, then you have the correct one. So just be careful not to use the geometry rotate component. So we're going to take the vectors that we've drawn here, put them into the V input. We need more information for this to work. So X is the rotation axis. So if we look here, we have an X-axis, a Y-axis, and we're actually going to be rotating them around the axis that is coming towards us in space, which is the Z or Z-axis. So I'm going to come here under the vector, and I'm going to just drop a unit Z component onto the canvas for that, that particular rotation axis. And finally, to finish the rotation, we need to define an angle. By default, this is in radians. It's more intuitive to put it in degrees for most people, so we're going to do an angle in degrees. And I'm going to drop a slider onto the canvas. I'm just going to type 125, enter. But I'm going to go into the slider, double click that, and I want this to be between a minimum of -180 for the minimum amount of rotation, and a maximum rotation will be 180. So that will allow us to go through the whole 360 degrees of rotation. You could also do between 0 and 360, but we'll just do -180 to +180, and we'll have a precision of just 1 decimal point. So 180.0. And I'm going to drop that into the angle. Now I do have to remember to come here to the A on the input, right click that and change that to degrees to make sure that that is being done in degrees. The alternative is to drop a component, this radians component, which will convert this degree into radians, and then I could input that into A if I don't do this override. But we're just going to use the override, which just makes it a bit simpler and cleaner without too many components on the canvas. So we want to preview our rotations now just to make sure it's working. So instead of using these vectors to preview, I'm just going to use those vectors to preview. And now I can change this angle between -180 to +180, which is the same thing because it's rotating around. So this will be our overall field, and we have generally two parameters for that, this factor here and that angle there. I'm going to rename them, and this factor, I'm just going to rename that overall vector field strength is parameter 1. And the second parameter, I'm going to rename that to overall vector field angle. And I like to group my parameters. So I'm just selecting those two, right click, put those into a group, and I like to color them red. So right click on the group itself, and let's just change that color to red. So that I know that those are some of the parameters that I can change to change the overall quality of the vector field. So I'm going to do one final thing. I'm going to take these vectors and I'm going to drop them into a vector parameter container. So here under geometry point, the second one is vector, and I'm just going to drop them into here, group that, and I'm going to right click that, and I'm going to name this group overall field vectors. So we're going to continue, but before we do that, we're just going to put aside everything we've done so far, just so we can focus on the next step. We'll come back to the overall field by the end of this. But now we want to focus on the vectors from what I'm going to call emitter points. I'm going to take these points here, and I'm just going to copy that point container, which are our base points, and I'm going to turn the preview for that back on. So it's the same set of points, just in a different container, just so we can focus now on this second step. So I'm going to come back here into the Rhino interface, and I just want to draw at least one or two or three. I'm going to draw 3 emitter points. We can always change that later. We can add more or fewer. And I'm just going to draw multiple points and just draw 1, 2, 3 points, and I'll push enter. So now I want to take these points I've drawn in Rhino. I want to input them into Grasshopper. So here under parameters, geometry, point, drop that on the canvas and right click that point container and set multiple points and just select those points that I've drawn in Rhino. So I have 2 sets of points. I have my point cloud, my random set of population of points, and I also have my emitter points. Just to help clarify things, I'm going to put this into a group, right click the group, and I'm going to name this emitter points from Rhino. And I'm just going to change the color of that group to red, just as that is a parameter that we'll want to be able to change later. And I'll take this set of points, put those into a group, and I'll name this group random vector base points. I'll just call them vector base points, get rid of the random. So my vector base points and my emitter points from Rhino. So the next step I'm going to do is I'm going to come here under the vectors and set up the vectors themselves. And I'm going to use the vector 2-point component. Between the A input will be the vector base points, and the B input will be my emitter points from Rhino. And now I just want to preview that just to see what's happening. So I come here under display, vector, vector display. and I'll use my base points as the anchor, and we'll preview that. So there is a problem that's popped up. You can see that this is our first point we've drawn, our second point we've drawn, and our third point. And so basically what it's taken is it's taken the first list of points, and it's taken the first vector base point, and it's drawn a vector between that and the first emitter point. It's drawn a vector between the second item in our vector base points, and it's drawn a vector to the second emitter point. But then all the remaining base points go to the same emitter point. And so the problem, you may have guessed it, is with our data structure, because this is a flattened list and this is also a flat list. But we want the same operation to be happening between each one of our emitter points. So we have to come here under emitter points, and we need to right click that, and we need to graph that so that it is drawing a vector between each emitter point and each of the vector base points. And now it's drawing that. Now what we want to do is we do want overlap, so we're not going to use the closest points component because we do want our fields from each emitter point to overlap, which will give us results. You'll see that at the end. But what we want is we want the strength of the vectors to decrease the further we get from each one of our emitter points. And if you followed some of the previous examples, you'll know, especially the previous multi-point vector field example, which I'll link in the description. You can watch that for more details. What we do is we measure distances, and then we use those distances to change our amplitude or the strength of the vectors. So I'm going to come here under vector, we want the distance component, so vector point distance, and we're going to get the distance between all of our base points, which will be input A, and the emitter points we've drawn from Rhino. And so now that's giving us distances. We also want to put onto the canvas right now this vector amplitude component. So amplitude will allow us to change the strength of the vectors. So I'll just put that onto the canvas here. And if I take my vectors themselves and we use the distances as the override, we'll just preview how that's looking. Well, it hasn't really changed anything because it already was using the distances to determine the vector length. So how are we going to get these vectors, the distance, to decrease the further we get away? And the solution to that is to invert our list of distances by subtracting them from a value. So we'll come here under Maths, Operators, Subtraction, and the first number will be a constant that we'll fix. The second number will be the distances themselves. I'm going to drop a slider on the canvas. I'll just type 1.5 for now. We will change that later. This will be a variable parameter which will allow us to change our vector strength. But we'll put the distances into input B on our subtraction. And now, if I use those subtracted distances, you'll see that, well, it's still a bit of a mess, but currently these far away ones are getting a strong distance, because what's happened is, and let's just come in here into the draw a panel onto the canvas, is we have a lot of negative distances. So those negative distances, when you're subtracting, are creating this effect where we're kind of exceeding in the negative direction the distance function. So to solve this particular problem, what I'm going to do is I'm going to put a cap on the outputs of this distance function, or basically a floor. And what I'm going to do is come here under the Maths tab, Utilities, and I'm going to put a maximum component. So what this will do is it'll allow me to return either only positive values, and for input B, I'm going to drop a panel onto the canvas, so double click, double quotes, 0. So that will be my second value, and so basically what this will do is it will return only positive values. Now currently, I don't have many or any positive values. We'll just put this into the preview. So if I take the result of that and drop that into amplitude, you'll see that now I'm not seeing any vectors at all. And so what I'm just going to do is take this, temporarily increase that, what the value I'm subtracting from, and you'll see that now when I'm subtracting from a larger number, let's say 7.5, that I start to get close to my emitter points some vectors. And you can see that the closer points to the emitter points are getting larger vectors, and further away they're getting smaller, and at a certain point that stops altogether because of this maximum function that I put. So we do know that the logic is working properly, but there's one thing we want to do to the distances to solve our final problem, is I'm going to take my distances, and instead of them being, let's just drop a domain, a bounds component onto the canvas. So domain bounds. And so this is giving me, let's put a panel here. It's giving me the bounds from each point. So for first point, the distances are between 2 and 46. Second point, 3 and 51. You'll have different values because you will have your points in slightly different locations. So what I want to do now is take those distances and remap them to a smaller domain so that we're not getting these really extreme values. So I'm going to come here under domain again, remap numbers, and for the first input for the V, the value to remap, so I'm remapping the distances, and the second value is the source domain, so this is the domain of the distances, so that will be the output from the bounds component will be this, and for the target, I'm going to put a slider so that I can change. So currently it's 0 to 1. Let's just put a slider 2.5 onto here, and this will allow me to change the new domain, which are the results which are coming in here, and I'm going to put that in to the subtraction instead. Yeah. And I'm going to decrease this value here. So, and let's just decrease the target domain, or increase the target domain. Let's say 10. Let's put this as a number higher. Let's put a max of 30. And so basically what this is now doing is this parameter is influencing the rate at which the vector strength decays. So I'm going to rename that rate of vector decay. And this second value, the first value, sorry, will change the kind of strength, the initial strength. So strength of initial vectors. And I'm going to take these two parameters I've established, and I'm just going to put those into a group and color this group red, because that is a parameter that we will want to be able to change later. So let's just come here to the field itself. Let's just increase the point count quite a bit, around 400 points. And I'll come back here, and you can start to see, let me just turn the preview for those off, the preview for all my points off, and you can start to see the rate influences the radius as well. That at some point, these vectors, the emitter effects are starting to overlap. And so that'll lead to our next step, where we're going to start to take all of the vectors that we've drawn so far, so the vectors from our three emitter points, but also the vectors from our overall field, and we're going to start to sum those together. So now what we want to do is we want to start to sum together this set of vectors. I'm going to put them actually in their own container. So I'm going to come here under parameters, geometry, vector, and I'm going to put them into this container. And I'm going to just put that into a group. So select that, group that, and I'm going to name this emitter vectors. And so let's just see. So we have our emitter vectors and our overall field vectors. Let's turn the overall field vector display back on. So what we want to be doing is summing those with each one of those. Now there's something we want to check to be able to sum these, and this has to do with the structure of the data. And let's just put a panel to preview what's coming out of my overall field vectors. So here's the panel. So this has a simple flattened data structure where I have items from 0 to 386 because I have increased the number of points. Let's look at the results of my second set of vectors. So let's just put a panel there as well. So I have numbers. You can see here that I have numbers from 0 to 386. 0 to 386. So I actually have a more complex data structure here. You could kind of see the preview of that. So to be able to sum these vectors with these vectors, we actually have to have a identical data structure. So we're going to have to do this in two different steps. First, we're going to sum the emitter vectors together to get a single list that is similar to this, and then we can sum the overall field vectors with the emitter vectors. Now to sum the emitter vectors together, we have to make a manipulation or a change to the data structure as well. So to change the data structures, we come here under set tree, and the component that we want is this one called flip matrix. I'm going to drop that onto the canvas, and you can see the results of this is it is basically putting the first point from each of the vectors into a sublist. So this is a list of the first point from emitter 1, the first point from emitter 2, the first point from emitter 3, second point, etc., etc. So to sum vectors, let's just keep that there. To sum vectors, there isn't a special component. I was actually looking for this for a long time, a vector addition component. It's the simple normal addition components will allow you to sum vectors as well. And so we come here under maths, operators, addition. But we have to sum together three values, 1, 2, 3. So I'm just going to add a component there. And I'm going to come back, and from this, I'm going to do a list item component. So here under set list item, and this will list item 1 in each individual list. I'll put that into A. Then I want to add item B from each individual list, item 1 and item 2. So 0, 1, 2, 0, 1, 2, and this will allow me to sum each component on each individual list. And so now this is the sum of these vectors. Let me come here and let me just turn the overall vector field preview off. And instead of having that preview, let's get the preview, preview of the sum together vectors. But now the results of the mass addition, I can now sum those together with my overall field vectors with the simple addition component here, addition. So I'm going to have that added together with that. And since this list here now has the same data structure as that list, it should work when we sum these together. So that is now giving us the sum together of our overall field, and then the emitters also sum together. So these are the 4 sets of vectors, in this case, summed together. Let me just decrease the emitter field strength ever so slightly. Increase, decrease. And I can also change that angle. So as I increase this, the emitter, the overall field starts to take over, you can see. If I set this to 0, I only have the effect of the emitters. So we just have to find something in between. Now there's one other thing I want to add just to allow me to make this just a little more interesting, and that is currently our emitters, the vectors are going in a positive direction. What if I were to reverse those vectors with the reverse vector component? So that's found here under vector, vector reverse, so right here. And if I reverse these and make them negative, then that will also change my direction. So to do that, I'm going to use a dispatch component. So here under set list, I have the dispatch. And this will take a list of items, and based on a Boolean parameter, a true or false, it will either send this list into output A or into output B. So I'm going to come here under the first tab, parameters, input, Boolean toggle. So this will allow me to change that value between false or true. So when true, things are being dispatched into list A. When false, things are being dispatched into list B, and list A is empty. So the results of this will be, if I'm going to use list A, let me just add a vector parameter here, so that's parameters vector. I'm going to use those results, and if I use list B, I'm going to use the reversed results. And to add 2 inputs into this, I just need to hold down Shift, and this will let me add 2 wires into the same component. And then the results of that will be added together. So now that I have my basic logic set up and my controls seem to be working, I'm just going to go back here to the beginning, and let's just go big. Let's just go to 1,000 points, and we can see how our field is working and how it's flowing. So we have that overall field and then the effect of the emitters. Now you will notice here it looks like the vectors are overlapping, and you may ask, like, I thought we were summing those together to basically not have this kind of overlaps. And just remember, the vector only applies at the point itself. This arrow here is only a preview, and you could think of it as wind speed. If you're at a certain point, there can be very calm wind, there can be very intense wind, but at another point down the road, that wind will change or be different. But the wind speed only applies in the particular point that you're at in the moment. So a better way to show the preview is actually to use our vectors to orient some pieces of geometry that we will draw. So let's just turn the preview for this off. And let's just also turn the points off. And I'm just going to use a simple component to begin with here under curve, primitive line SDL. So the start of our lines will be our base points, and then the direction will be the vector itself. I should probably put my vectors into a container, so parameter vector here, and I'm going to put this into a group, and I'm going to call this summed vectors. And just to make this a bit clearer, I'm going to copy that and paste it, and then put this over here. This will be vector base points. I'm going to right click this and turn the preview of this, the wire, to hidden, so that there's kind of this wireless transmitter, and that's just the way to keep your scripts a bit cleaner. So the base points are here, the direction is there, and then the length is something I can change. And I could put a slider there, so let's just put 1.25, and now I can kind of change that. Now, what I really want to do, though, is I want to have some pieces of geometry. These could be any piece of geometry, it could be, but let's just do triangles. And I'm going to try to do this a bit simpler. And I'm just going to draw a simple triangle in Rhino. So that's my triangle. And I'm going to put that into a geometry container. So here, geometry. Right click that, reference that, and let's just set that piece of geometry there. I'm going to put this into a group called geometry to orient. Okay, so instead of using the line SDL, I'm going to use this, and I'm going to use a command called orient to do this. And so here under transforms, Euclidean, orient, this will take a piece of geometry. So the G is the geometry input. The source is the base point of our geometry. And that could actually just be, let's just make it the center point of our triangle. And then we just need to sort out the B input. And so B input, it's asking for a final plane. If I just dump my summed vectors in, nothing happens, because what I need to do is I need to use my vectors themselves to construct what's called a plane. And so if I come here under vector plane, there's a number of components here that are used to construct planes. The one I'm going to use right now is this one, construct plane. Drop that on the canvas. And it's asking here for 3 inputs. 0, so O is the origin, and so that's our vector base points. It's quite messy in the preview, so I'm just going to turn the preview for that off for now. But it's asking, so the origin, so there's going to be a plane constructed at each one of these points. And one is going to be in the x-axis direction. And then we need to orient to the y-axis direction. Now if we look at my shape, my triangle, the up and down, so the y-axis is the direction I want my triangle to face. So for the y-axis, I'm actually just going to use my summed vectors. Now what about the x-axis? Well, basically we just want the x-axis to be the y-axis rotated 90 degrees. And so I could just come here under vector rotate, So not the geometry rotate, but the vector rotate. And for the vector itself, we're going to be rotating these vectors, and we're going to be rotating them around the axis facing towards us, which is the z or the z axis. So it's going to be rotated around the unit z axis, and the angle, it's just going to be 90 degrees. So I'm just going to do a panel, double quotes, 90, and I'm going to put that in for the angle, and then make sure I set my angle to degrees. So right click on A, set that to 90, and we're going to use that for the x-axis. Now if I input that now into the orient plane, I should get these nice triangles. We don't need this line anymore, so I'm just going to delete that. And so now if I zoom out, we have a series of triangles which are oriented to the vectors. And now if I come back and if I change any of these parameters, the field strength, the field angle, I should probably just put all these together. Just put all these at the beginning. The count, field strength. There's a number of other things we could do. We could also, we don't have to use this kind of geometry. You could draw basically anything. Let's just try something. And the way we set this up, it has to be a closed piece of geometry because it has to be able to take the area to find the center point. So that's a bird. Let's set that as our piece of geometry to orient. And so now it's done this flock of birds. Let me just scale that down a bit. Just make the birds a bit smaller. So yeah, you can orient any piece of geometry you want. But let's just go back to our triangles. Because we have this vector strength, but currently I'm not accounting for vector strength. So I'm just going to do one more thing to bring this to a conclusion, and I'm going to be coloring these triangles based on the strength of my vectors. So if I come here under the Surfaces tab, Freeform, I'm just going to do a boundary surface at each one of my reoriented planes. And then I'm going to come here under Parameters, Geometry, and Parameters, Gradient. And let's just change our gradient colors from kind of a light blue to a darker blue. To do that, I just click on these control points on the gradient, and I can change right click on those, and I can change the hue. So we have these. I'm going to just take the area of my triangles. They all have the same area. And actually, I'm not going to take the area. So now I have my gradient, and I want the color of each individual triangle to be assigned based on its vector strength. So if I come back here to my vectors, the summed vectors, I'm just going to copy that and paste it and then put it next to my gradient just to make this a bit easier. And I'm going to come up here under the vector component, and I'm going to compute the length or amplitude of a vector. So here, that's giving me the vector length. And then I'm going to come here under maths domain bounds to find out what is the shortest and the longest vector. So I have a range from 0.3 to 10 currently. and I'm going to get from this domain, deconstruct domain. So that'll give me the start and the end point, and I'm going to use the start as L0 input and the end as the L1 input. So I'm going between the shortest vector will get this light color, and the longest or strongest vectors will get the darker color. So anything towards 0.3 will be cyan, anything towards 10.2 will be dark blue. And then I'm going to get the individual length, the t, which is the length at the thing, and then I'm going to use here under display, display preview, custom preview, and I'm going to input the geometry based on that. So our strongest vectors are now blue, and the weakest vectors are this lighter cyan type color. You could go further than this. You could extrude these. Actually, on my blog, I extruded them based on their strength as well. So the darker blue ones are taller, lighter blue ones are shorter. Let's just do that very quickly. Come into the perspective view, and let's just do an extrusion. Extrude command. Extrude. And so I'm going to take these and I'm going to extrude them in which direction? In the Z direction, or Z direction. So vector unit Z. And the amount I'm going to extrude them is based on the strength of the vector. So I'm going to use that for the amount. I'm actually going to just divide that by a factor, just to make this a bit easier to see. Just divide it by the number 3. I think that'll give us good results. And then we'll use that for our custom preview instead. Turn the preview for that off, the preview for that off. So now I have a series of triangles which are extruded based on the vector length, but they are also colored based on the vector length or that amplitude. If you would like access to a cleaned up, completed version of this script, you can visit my blog, generative-landscapes.com. Link provided in the description to download this along with 2 other vector field scripts. This particular version has 2 different versions. The one as in the blog with an addition of customizable triangles to change the preview of your script. And then the version as described in the video. I'm going to turn the preview for this off with the birds. Or you can put in any customized piece of geometry you want. You can draw, just anything that looks interesting to you. And you can reference that. That's not that interesting, to be honest, but maybe you can come up with something a bit more interesting, and it will orient that to your vector field. So if you would like access to those and to help support the blog and this channel, follow the link in the description. Thanks for watching.